All right. So in the last class, we were discussing about the rate of change of function when the when the graph of a function is not a straight line, and then we have I think you remember that we have shown you some differences. If you look at this picture, let's see. So you remember that we just have two different points, and we are just trying to see the change of function, just having the formula applied here, and we also know that the change of function is constant for every straight line. But since this is not a straight line, the change of rate it depends on the points you are picking. Okay, because if you pick another another pair of points, then obviously the functions, and because the value of the function will be different. I'm saying still the function is the same function, but f of like f3x3 or f of x4, those will be different points, and their values will be different. So using this rate of function, we will apply the same concept into difference quotient. Remember, we in a couple of I think in section 1.2 we discussed about this difference quotient. This difference quotient is extremely useful in calculus, any discussion in calculus. So since we are not discussing about the calculus, but still we want to learn about this difference quotient, so we'll also show you that how the difference quotient is applied in this, the rate of change is applied into difference quotient, because you see, if you compare these two functions, they're pretty much same. Because in the first function you have 2 points, one was x and other one was x1 and x2, and since they're different points, we know that they will have different value for f of x1 and f of x2. Same is for the next one. If you replace the x by x1 by x and x2 by x plus h, your function will be your formula will be replaced by this. And what happens in some discussion, like I think we are discussing that day in calculus, in somewhere where people try to take the slope, because we are already introduced to the slope, but what we did is we just calculate the slope for a line, right? In several discussion in mathematics, you have to calculate the slope in one point. Okay, theoretically that doesn't make sense, because whenever we are talking about the slope, we always need 2 points, right? Because when you are trying to calculate the slope, you always need 2 points. But what happens that when your line is a curve, for an example, let's say you have line like this, and let's say somebody said, what is the slope in this point? Because in case of a straight line, you know exactly what will be the slope, because your slope will be constant for every single point in the line. But in case of the curve, what happens is your slope will be changing every time you are changing 2 different points. Based on that, it's changing. Okay, so that's why instead of taking slope between pairs in some discussion, we are interested to take a slope in one single point. Okay, and then this difference quotient come into the picture. What we do is we assume that this h is extremely small. Okay, so if it is extremely small, for an example, like point and then 20 zeros and then 1. You see, this is not 0, but that's extremely small. But if we assume that this point and x plus h, I'm saying x and x plus h, there is still 2 different points. But they are so close, because h is so small, that they are so close that you can assume there is one single point. And that's how basically we take the slope. And this is one of the example where slope is telling you that how the line or rate is changing, because if you take a slope of this line, for an example, it will look like this. Oops. If you take a slope of this line, it might look like this. But if you take a slope of this line, this point, it will be like this. Okay? So you see, probably the slope is changing like this. Because for an example here, if you take a slope of this point, it will be like this. Now, the reason of this discussion is because this difference quotient is used to calculate this kind of slope when you are taking the slope in one point. Okay? So for now, we'll be just applying our formula and see whether we can find the difference quotient, and we use this difference quotient as a I think that's in section 1.1.2, not in 2.2. Okay, so again, this is an example or application, real life application of how you can use that rate of change. When a person receives a drug injection, let's say, the concentration, the drug in the blood is a function of hours elapsed after the injection. Okay. Now let's say this graph is basically telling you that how the concentration, how much drug you have in your blood after how many hours. If you look at the graph carefully, you'll see at the beginning hours, at the very beginning, where it's probably 0 hour, you see the concentration is extremely high, okay? And over the time, the concentration is decreasing exponentially. But after a while, for an example, after 6 hours or after 7 hours, it's extremely low, okay? It may not be 0, but it's probably a little bit higher than 0. So this graph is basically telling you that how that rate of concentration of drug is changing over the time. Now let's say you want to know some specific question, okay? You have a specific question. Now what is that question? Now here, as I said before, that here we are using the x as the hour and y is the concentration. The reason is, using this graph, we want to find the concentration after some hours. So your hour is a independent variable, okay? And using the hour, you will find the concentration of the drug in your blood. So that concentration is what you want to know based on the hour. Now look at the question A and B. In the question A, we want to find the average rate of change of drugs concentration between first and fourth hour. Remember, we are just trying to find the rate, not the amount, because we just know the amount from here. For an example, let's say we know that in the first hour, this is the first hour, right? Let's say these are all milligrams. Okay, so we know that in the first hour, the drug concentration is 4 milligram per liter or per cc or whatever. Now, you know that at the fourth hour, the drug concentration is a little bit less than 1 milligram per cc. Now, you know that, but what is the rate of change? That means how the concentration is changing over the time. Okay, because we know that that's decreasing, right? The function is decreasing, but how it is decreasing? What is the rate? Because maybe the rate is too high, maybe the rate is low, because as you can see, you probably can realize that let's say between the first and fourth hour, the rate is quite high because you see the slope is quite sharp. But for an example, let's say somebody asks me, what is the rate of concentration change between third and fourth hour? You will realize, for an example, in the third hour is here, right? So you will probably have a point here and here. If you draw a line, it will be like this. It will be a little bit less sharp than this because the rate is not that sharp, because the rate of change is not that much. Because at the beginning, the rate was extremely high because concentration was decreasing at a very high rate. But if you look at the later hours, the concentration is decreasing at a slower rate. Even after, let's say, 5 or 6 hours, concentration is still decreasing. It's not 0 yet, but it's decreasing quite slowly. Okay? So this kind of question you can answer from the rate of change of slope. All you need to do is you have to apply the formula we know, and then see whether, okay, let's apply the formula here. For an example, you know the point here, right? For an example, you know this is first hour, so this is 1, and the concentration is 3.96. Fourth hour, concentration is 4.2, okay? And all you need to do is, since the formula is f of x2 minus f of x1 over x2 minus x1. Now, as you know from the beginning, doesn't matter which point you assume 2 or which point you assume 1. It's up to you. You will have the same answer. Let's say, so let's plug those values and see, let's see, 3.96 minus 0.72 and 1 minus 4. And it should be done. Remember, the rate can be negative. And this is going to be a negative rate. Anyone has any answer that why it is negative? Because it's decreasing. Yes, you are right. Since this is decreasing, the rate is negative. So, you know, you can just from the answer, you will also know that whether the rate is decreasing or increasing. If it is increasing rate, it will be always positive. If it is negative, that means it's a decreasing rate and it's negative. So it doesn't matter how you do it. I'm saying which points you pick, it will be always negative. So if you look at the question number 2, what is the explanation of this rate change? Once you have it, what is the answer? Anyone has the answer? Negative?
Negative 1.08 or
1.5? 08? Okay, let's say it's 1.08. Now, what is the explanation of this answer? The explanation is the drug concentration is decreasing at the rate of 1.808 between first and fourth hour. Okay, the rate is per hour for sure, but as you know that the rate is changing. If doesn't matter, I'm saying if you let's say calculate the rate between 1 and 3rd hour, the answer will be different. Okay, because your points are changed. So that's why we have to mention that this is between 1st and 4th hour rate change per hour at an average rate, because at this point you are saying this is the average rate of change, but this is basically, in reality, this is not the rate for every hour, right? If you look at carefully, probably from the 1st and 2nd hour it was more sharp than this, because it will be like this. Okay, for 2nd and 3rd hour it was little bit less sharp than that. For 3rd and 4th hour it was again lesser sharp, but at an average it was 1.08 between 1st and 4th hour. Okay, let's see whether we can understand another example. Okay, sometimes it takes a while for a drug to diffuse sufficiently to affect the desired organ. The curve below is a close approximation of the concentration in that organ compared to the time after the drug was taken. It's a similar example. So again, you have concentration and hour along x-axis and concentration along y-axis, and these are all the points you have for all different hours, all the way from 0 hour to 5 hours. Now the question is asking what is the average rate of change from the time the drug was taken until the 1st hour. So basically you are trying to see the rate of, so you're trying to see the average rate of change from between 0 and 1 only, right? So your points are only these two. This is the 0 hour and this is the 1 hour, right? So if you use these 2 points, you should get your answer, and you have to find the slope. Next question is the same question, but average rate of change from 2nd hour until the 4th. So you will take this point here and then 4 hour point, right? Because you're trying to find these 2 points. You're trying to find the average rate of change between, and again, as I said, always it will be a different answer, because since this is not a straight line, based on which 2 point you are taking, your rate will be different. And the last question, what is the interpretation? As you know, the interpretation is you are trying to give an average rate between an interval, right? You're saying that, okay, this is the average rate of decrease or increase, because you see, can you tell us, is the graph increasing or decreasing? Neither one, because its first half is increasing, second half is like decreasing, right? Because you see, from the beginning to here, it was increasing, right? From here, it's decreasing again. So if you probably like find the slope between this to this point, then the slope will be positive. But anytime if you look at the slope here, your answer will be negative, because the second half of the graph is decreasing. So the concentration is decreasing. At the beginning it was increasing. But whatever it is, your answer will be whether it is increasing or decreasing, but your answer is the average rate, okay, between that interval. For an example, between like second hour and fourth hour, or first hour and third hour, right? Something like that. So these are some problem from the last chapter. Let's see. Let's pick one from each section. These are the 3 different types of problem we covered in this section. Okay, in section 1.5. Let's say we pick the last one from here. Let's see whether we can do that. I think we are familiar with the problem, right? This was the first problem we dealt with, that we are given one line and we have to find the equation of another line which is parallel to this line, okay, and which is passing through a point which is 4.5, for an example here. So, oh, I'm sorry. So the equation is given. I thought probably the equation was here. I thought the equation is not given and you have to do for all of those 4, 5. So equation is given for you, so this is only one problem, not 4. So and you have to just tell us what is the right answer. Okay. Now remember, the hint is for the parallel lines, the slopes are equal, right? So your equation is given. So whatever the line you will have, you will come up with, that will have the same slope like this line, the equation that was given to you, right? And these are your options. Let's say this is a multiple choice question. Okay. So to see whether you can do that. So first find the slope for the line, and then so all you need to do is you have to change the format of the equation, the form of the equation, such that you will know the slope. Once you know the slope, use that slope and use this point to come up with the equation of the new line. the answer? B. Everyone has answer B? This one? Okay, let's see. The slope will be 3 over 5, which is here, right? Anyone has a different answer? Okay, so let's try the other problem. So which is the same kind of problem. The only difference here is the line is parallel. So once you have the slope from that equation, you will take the reciprocal and you will just do the reciprocal of that slope and make it negative. And that is going to be your slope for the new line. Do you see the right answer? I think something is wrong in the question. I'm sorry, in the answer, because the slope should be 3 over 8, negative 3 over 8, right? So just ignore the question. I think the answers are same, it's not changed. So what is the answer? What is the answer you have? Can anyone tell me the answer? It will not be matching with these, because these are not right choices, because none of the slopes are 3 over 8, negative 3 over 8. The slope is negative 3 over 8, right? Yeah. So your formula should be this one, right? Y minus y1 equals to m times x minus x1. You replace the m by negative 3 over 8. And x1 is negative 1, and y1 is 3. So it will be y minus 3 equals to negative 3 over 8, x minus 1. And the last question we have, excuse me, last question is about the rate of change. And as you see here, we have 2x, x1 and x2. We'll find the slope in this. We will just find the slope between these 2 points, right? and that will be your rate of change. Any question at this point? Have you received my email? Do you check the Southwest emails? Check the Southwest email periodically, because I sometimes used to send an email, because last night I received some emails from some of you, and also we could not finish the section 1.5 by Friday, so I extended the deadline for 1.5, and also I changed the deadline for 1.4, because I saw that some of you could not finish 1.4. Probably you were rushing because you started late. I know that this is the first time, this was the first deadline, Sunday. So you will be able to submit the section 1.4 up to tonight. This is still open. I extended the deadline, so it's still open, and section 1.5 by tomorrow. How about that? Is it okay? And the other deadlines are still same. Yeah. And we are not changing any deadline to the quiz, because we don't have any quiz until next Sunday. So I'm hoping that we'll be able to finish up to 1.8 of section chapter 1. So the quiz one will be on chapter 1. So we are probably all set. And just let me know. I think if you're having any question or anything about my MATLAB, just send me an email, because I received some email from someone yesterday. It was Sunday, for an example, let's say evening, regarding the course code. Okay, but it was too late, because when you ask the question so late, even if I answer, it will be really difficult for you to catch up. Okay, so make sure you answer a little bit early, so that I can answer, and then I will answer definitely for sure. But sometime probably, like, let's say for an example, I need 2-3 hours, because I don't check the email, let's say within 2-3 hours, and if you really ask the question extremely late. So, but you can always ask the question about my MATLAB, because what I noticed is I thought, let's say I have seen some of you are scoring like 94 or 95 or 93%, but you just tried one time. Okay, so what I felt was, if you have tried it one more time, you could have got 100%. That's what I thought, because since you are getting more than 90% in first time, and we opened all those unlimited items for you, so you should take those advantages, so that you can improve your grade. All right, let's see.